Flashlight technology has come a long way since 1899 when British inventor David Meisel obtained a US patent for an electric device using newly invented D-sized dry cell batteries. When he introduced the handheld light, he initiated a revolution in lighting. Since then, flashlight design has made remarkable progress. Both light bulb and battery technology improved significantly, and the trend is continuing. The basics of flashlights. The flashlight uses batteries that contain stored DC energy. Connecting several batteries together, in series, with a conductive metal strip, an on-off switch, and a bulb creates a flashlight. When the on-off switch or button on the flashlight is closed, the circuit is complete and the bulb lights. Add more batteries and a different bulb and you can realize an even brighter flashlight. The flashlight can be left energized, providing continuous light until the batteries discharge. Then the light bulb goes out and you must install new batteries to get the light back on. Be the first to get your hands on the world's best tactical flashlight. A flashlight creates a beam of light that illuminates objects nearby or distant depending on the power and shape of the light beam. As the distance from the flashlight increases, the beam spreads out and the illumination gets dimmer. The beam can be broad or narrow depending on the flashlight's design, creating a spotlight or a floodlight. Consumers evaluate and compare flashlights by the lumens of light produced, the strength, reach of the light beam, and how long the battery will last. Size and weight have consistently been reduced, so today portable lights like these can weigh just ounces. A flashlight can produce light output from less than a lumen to over 3,000 lumens. Just 20 lumens is all the light you need to read this article in a dark room. I remember when I was a boy and it was bedtime. I often hid under the blankets reading comic books with a flashlight until I became too tired to stay awake. That makeshift light worked well in my small reading cave. Flashlight designs. Today there are hundreds of flashlight designs for sale. A visit to a local home improvement or camping supply store will show a myriad of selections. You'll find pen lights powered by a single AA or AAA battery. You'll find handheld flashlights sized from several inches to over a foot long with batteries that energize tiny incandescent or LED bulbs. And you'll see keychain flashlights, general-purpose household flashlights, spotlights, floodlights, tactical lights, headlamps that provide hands-free movement, and even use once glow sticks that give off a greenish light for up to 12 hours. And there are multi-mode flashlights with switchable brightness controls that make the device bright, dim, strobe, or flash an SOS in Morse code. I even found a few flashlights with a zoom capability and multiple brightness levels. The ingenuity of the human mind is endless. One type of multimode flashlight uses two AA, alkaline or nickel metal hydride, NiMH, rechargeable batteries and has 3 brightness settings. The standard setting will keep the bulb energized by alkaline batteries for just over 2 hours. The NiMH batteries will keep the light energized longer, about 3.5 hours. Switch to bright light and the batteries will last a little over an hour. Set the flashlight to the lowest, dim, setting and the batteries will keep the light bulb energized for over 9 hours. Incandescent versus LED. Most families have at least one incandescent bulb flashlight, but light-emitting diode, LED, flashlights are rapidly becoming the norm. The LED light uses less battery power, is brighter, and lasts longer than its incandescent predecessor. An incandescent bulb can produce 8 to 10 lumens per watt. An LED can produce 100 lumens per watt, but LEDs need more battery voltage to operate, 3.4 to 3.7 volts versus 1.5 volts for incandescent. This is why keychain lights and tiny pen lights still use 1.5 volt incandescent bulbs. Incandescent flashlights using alkaline dry cell batteries have been the standard for years, while small LEDs were used mainly as low-power indicator lights. Then in 1999 a white light LED flashlight using grouped LEDs was invented, creating bright light with efficiency and runtimes exceeding that of incandescent flashlight bulbs. As the popularity and use of LED flashlights continues, they are replacing the incandescent as the practical flashlight of choice for main use lighting. Flashlight performance. For emergency lighting, you don't need the 100 to 250 lux, 929 to 2300 lumen brightness, common to room light with full electrical power. When power is out, 35 to 100 lumens will usually suffice for brightness during normal use, with 8 to 20 lumens adequate for moving about between rooms. The idea is to use natural light during the day and emergency lighting after dark, adopting a circadian schedule whereby sleeping prevails at night and most of your activity occurs during daylight. Once you decide on the purpose you intend for the flashlight you seek, selection is made by performance. Here you want to know lumens of brightness, how far the light beam is usable, the type of battery and how long it will provide power to produce light. Emergency flashlight. In 2009, the American National Standards Institute, ANSI, published test and rating standards for all flashlights. Floor 1. Manufacturers were asked to print performance test results on the packaging. This is why you'll often see Floor 1 standard values such as lumens, beam range, runtime, and candela with signature icons printed on the front of many flashlight packages. Flashlight brightness. Flashlights with brightness between 1 and 20 lumens are good for keychains or small lights. A green glow stick produces 0.6 lumens of light. A general-purpose flashlight produces 30 to 100 lumens of brightness. A heavy-duty flashlight will produce 200 to 300 lumens of light. And high-powered flashlights produce 1000 up to 3500 lumens. The beam or throw value describes how far the light beam will shine, in meters, before the illuminance falls to 0.25 lux, the illumination of a full moon on a clear night. By mounting mirrors in a room and shining a flashlight up towards the ceiling, you can reflect the light beam and increase the overall brightness effect in the area. Reflectors are included in flashlights to focus the beam and fix the beam with angle. Angles of 20 degrees or more are considered floodlights. Runtime and batteries. Runtime describes how many hours the light can operate before the battery driving the lamp discharges to 10% of the voltage of a fresh battery. Many manufacturers make a graph showing light performance over time. These are usually available on their website or product literature. The type of battery used in a flashlight is important in determining runtime. Batteries can be disposable, rechargeable, or renewable using an external source of energy. Think solar and think manual hand crank. Battery types include alkaline and lithium disposable batteries, and lithium-ion, Li-ion, nickel-cadmium, NiCd, and nickel metal hydride, NiMH, rechargeable batteries. Lithium batteries cost more than twice that of alkaline batteries, but lithium batteries often last many hours longer. Lithium batteries should not be interspersed with alkaline batteries. Use alkaline with alkaline, lithium with lithium. With the rechargeable batteries, nickel-cadmium batteries give you the most recycles, up to 1500, followed by Li-ion with between 500 and 1000 cycles. NiMH batteries are good for between 150 and 500 cycles. Some consumers select emergency flashlights that all use the same type of battery so they have a simpler stocking issue. Others choose any type sold in stores because they want to have multiple options should the stores run low. The key is to have a good stock of backup batteries on hand. Emergency flashlights. One popular flashlight design that proved itself during emergency power-out conditions is the headlamp. It's also called a headlight. This device channels light to a specific area. Headlamp batteries can produce 11 to 120 lumens of light and last for 150 hours or more. You need brightness reaching out about 7 feet for walking at night. Lithium batteries are typically not used in headlamps. For example, the Rayovec 120 lumen headlight uses 3 AAA batteries. Headlamp headlight products produce between 11 and 120 lumens, with a reach between 9 and 40 meters, and a runtime between 5 and 12 hours. They cost between $14 and $20 each. Some of these have multiple modes of operation. Flashlight options went from 8 to 3500 lumens and reached out, beam thrill, 12 to 391 meters, with operational battery lives between 1 and 50 hours on the brightest setting. Prices varied from $1.97 up to $70, with incandescent versions selling for much less than products using LEDs. Cell phones are another form of emergency light. According to comments on various forums, cell phones are available with flashlight capability in the 8, 12, 16, 25, 40, or 50 lumen range of brightness, suitable for finding a keyhole, a light switch, or to illuminate your way through the house. A category of lighting called Everyday Carry, EDC, covers devices that are used working or emergency lights. The most popular EDC light manufacturers, in order of mention, are Phoenix, 23.8%, Streamlight, 10.5%, Brian, 5.6%, and Surefire, 4.9%. What are the most popular flashlights used by actual emergency survivors? To determine this, I read blogs and case studies covering major emergency events when electrical power was lost for over 3 days. I found over 60 makers and types of flashlights, headlamps, pen lights, and lanterns being used during these incidents. I also read flashlight product reviews to see what products are most popular today. 5 manufacturers were mentioned the most: Phoenix, 13.3%, Maglite, 13%, Streamlight, 10%, Ultrafire, 6.7%, and Innova, 3.3%. Survivors who prepared for emergencies selected multiple forms of lighting: headlamps, 1 per person, small pen lights or keychain lights, LED flashlights with various brightness, beam distances and run times, and 360 degrees illumination lanterns. By judicious use of these resources, few survivors ran out of light and battery power. They used ceilings, walls, and mirrors to enhance light coverage. And they turned them on only when being used, thus extending the run times out for days or weeks. A number of these survivors commented that neighbors, who failed to prepare, often found themselves stuck with flashlights that ran out of battery power, causing them to frantically scrounge around to find or borrow replacement batteries. Failing to plan is planning to fail, and this adage showed up often during these emergencies. By positioning flashlights around your home so you always have access to a device, you'll never be left in the dark more than a few seconds when a power outage occurs at night. Here's where knowledge is power, light power.